Okay, so now we will move on to the next topic that is known as dynamic programming. Now this topic, dynamic programming, is also one of the strategies to solve computational problems like your greedy approach or divide and conquer method. Now the term programming here has got nothing to do with source code or coding part. So dynamic programming doesn't mean that you have to learn a new programming language or something. No, programming doesn't mean, or here it doesn't refer to any programming language. The term programming over here, dynamic programming over here, is the way we try to obtain the result. That is how in sequence of steps we get the result. So the dynamic programming strategy, basics of the dynamic programming strategy is it is used when the term programming, actually that is what I was explaining, it is used when the solution is viewed as a result of sequence of decisions. That is, we make one decision, then based on that decision we make another decision, and so till we find the solution. Now let us consider we have a problem P. This problem P can be solved by subproblems, and these subproblems can again be divided into subproblems. Again, they can be divided into subproblems. And subproblems, it can go on. And the subproblem is solved. Then we come back to subproblem, which is solved using the solution of the subproblem. And then finally we get the solution for the larger problem. Now this might be a little vague in terms of looking at the diagram. But let us consider what we have already seen as the the knapsack problem. We have seen a fractional knapsack problem, remember. The next thing in dynamic programming, we're going to see a 0-1 knapsack problem itself. But let us consider the knapsack problem. If you remember that knapsack problem, we will have several items that can be filled in a sack, and sack will have a capacity, and the items has to be filled in such a way that we have to earn a maximum profit. So if you consider knapsack problem, let's say we have 3 objects. Among these 3 objects, we pick, let's say, 2 objects. And at each stage we have a decision to be made. So the first part is we have 3 objects. Among 3 objects we can select the decision we are trying to do. Is suppose if we select object 1, then in the next subproblem we can select object 2 or object 3. And the next decision if we make to select object 2, we have to select object 3. Now suppose if we select object 1 and we may not select object 2, we can select only object 3 as the second decision. The same way, if we say object 3 is selected, the next object 2 is selected, then again object 3 can be selected, cannot be selected, depending upon. So it's actually the way we try to solve these problems. That is one decision at a time. So this is how dynamic programming is going to work. So in dynamic programming, what we do is we perform sequence of decisions. And each decision is going to lead us to an optimal solution. Now, let us consider this. Let us revisit this knapsack once again. If at first stage, if we choose object 1, then in the next stage we can choose object 2 and object 3. That is why there are two arrows going. Now in the next stage, if we choose object 2, third stage we can choose object 3. But suppose at the first stage we are choosing object 1 and next stage we are choosing object 3, then obviously object 2 is not selected. So there is no arrow going to the third stage. So at every stage we are making a decision. Now if we select object 3 at the first stage, there is an arrow going to object 2. Can we select object 2? Yes, we can select object 2, there is no problem. But then from object 2 there is an arrow going to object 3. So can we select two objects at two different times in knapsack problem? No, that's not possible. So if you say that, see, the decision of selecting object 1, object 2 and object 3 is a correct decision. May be a correct decision, may yield a correct decision, maximum profit. And another solution is to select object 1, then select object 3. This may also lead a correct solution. The third thing what I said is from object 3 to object 2 to object 3, because there is an arrow, there is a decision. Object 3 is not possible. So remember that we at every stage we make decisions, but we also have to remember that the decisions what we make should lead us to an optimal solution, and those decisions should not be an erroneous decisions. Like in this case, when we select object 3, that's the first decision, then object 2, then we cannot select object 3. So remember, this cannot be. So we have to remember that always the decisions what we make lead us to optimal solution to the problem. Now let us assume that, say for instance, that we have a problem P and we have a sub-problem P2. Then this sub-problem leads us to a sub-sub-problem P2, which leads us to sub-sub-problem P, another sub-sub-sub-problem P2. And this sub-sub-problem P2 can be solved easily. So sub-sub-problem can be solved, so sub-problem P can be solved. So actually problem P can be solved. So assume that this green arrow is a sequence of decisions that we take, which leads us to an optimal solution. It leads us to a solution. Now there may be another path. For example, from problem P, a decision is made to choose sub-problem P3, which will give us sub-sub-problem P2, which can be solved using sub-sub-problem P2. So here we are having two solutions. There are different decisions at different stages. Different times that can be made. So remember that in dynamic programming approach, we will not just get one answer. We may get different answers, different results or different solutions. But all those has to be optimal. Now, this in general sense, the dynamic programming, when we are using this approach to solve a problem, you can remember that, you can observe that this problem, sub-problem P2 and sub-problem P3 are two different problems. But if we have the arrows, if we have two arrows, you look at this place, we have from the two arrows going to sub-problem 2 with sub-problem P2 and sub-problem P3. That means the sub-problems can be overlapping. So in dynamic programming, when we divide problem into sub-problems, sub-problems may be overlapping or they may not be independent. Remember this thing. Then each sub-problem whether it is sub problem P1 or sub problem P2 or sub problem P3. Each sub problem is solved only once. We don't solve these problems again and again. For example, if you have to find, if we have to make a decision from sub problems P2 to sub problem P2, and then again from sub problem P3 to sub problem P2, we will not be computing the sub problem P2 again and again. It's only done once in dynamic programming approach. And the results of this sub-problems, which is known as intermediate results, will be saved in a table. So always dynamic programming approach will be taking help of a table, and the decisions are made based on the values inside those tables. Then the optimal solution which we have to find, there may be several solutions like in greedy approach, but we need to find the optimal solution. So the optimal solution, what we need to find will be the decisions that are made at each level, one at a time. And as I said earlier, with the knapsack problem, we assume that every time a decision is made, it's a correct decision and it's not an erroneous decision. That is what will lead us to the optimal solution. Now there are several possible ways to do that. One of the ways to try all possible decisions and pick the best solution. Now, this may not be true, may not be efficient one, but it's the most simple one in dynamic program is to try all possible decisions and then pick the best solution. Now, to have an efficient way of implementing dynamic programming, we make use of the terminology that is principle of optimality. Now, what principle of optimality states that in an optimal sequence of decision, each subsequence must also be an optimal. For example, if we are computing the solution for subproblem P2, if this is optimal, actually we start from the bottom, we use a bottom-up approach. So let's say if the solution to the subproblem P2 is optimal, then it is guaranteed that when we try to solve subproblem P2, this also will be optimal, as well as subproblem P2 will also be, the solution to subproblem P2 will also be optimal. So that is what is principle of optimality, which states that in the sequence of decisions, when we consider optimal decisions, each subsequence decision must also be optimal. Then combining the optimal solution of this optimal solutions of the sub problems, we actually get the solution for the larger problem, that is P. So this is what principle of optimality states. So as I said, in dynamic programming, we use bottom-up approach. That is, we solve the smallest subproblem. We solve the smallest subproblem first, and then combine the solutions for the largest subproblems. Ultimately, we get the result for the solution for the larger problem. So dynamic programming always uses bottom-up approach. The smallest subproblem is solved first. Then, okay, let us compare. Last thing which we need to talk about is, in the dynamic strategy, algorithms will often have polynomial time complexity. Obviously, just to brush up, dynamic programming strategy uses solutions which are viewed as a sequence, the result of sequence of decisions, and then this strategy is used to solve optimization problem, whether it is maximization or minimization, And this strategy uses bottom-up approach, and the algorithms, when we use bottom-up approach, the algorithms will have polynomial time complexity. Now, we have seen, this is planning programs, one of the strategy. We have already seen one of the strategy known as divide and conquer. So let us now compare, before we try to use dynamic program approach and solve problems, let us compare, or let us see the difference, what is there between dynamic programming and divide and conquer strategy. अरे मियाँ मेरी क्लास चल रही भाई जरा आराम से बात करो. Now, in dynamic programming, we use bottom-up approach, whereas divide and conquer uses top-down approach. In dynamic programming, we take the smallest sub-problem and solve that first. But in divide and conquer approach, like the sorting, we take the larger problem, start dividing that problem. So we use bottom or top-up down approach. But in dynamic programming, we use bottom-up approach. Then divide and conquer approach, we know that merge sort or quick sort, all these things uses recursion. So then divide and conquer approach uses recursion, and dynamic approach uses iterations. Dynamic approach will use iterations. And the third thing is, in divide and conquer, when we divide the larger sub-problems, those sub-problems are non-overlapping. They are independent. They don't overlap. But in dynamic programming, sub-problems may overlap. In dynamic programming, sub-problems may overlap. So these are the few differences between dynamic programming approach and divide and conquer approach. Now, let us also try to look at the difference between greedy method and the dynamic program. In dynamic programming, we make many decisions may be generated. In greedy method, only one decision is generated which will lead us to optimal solution. But in dynamic programming, there may be many decisions or many sequences that may be generated which will lead us to optimal solution. But in greedy method, only one decision sequence is generated that will lead us to optimal solution. So that is what is the differences or basics about the dynamic programming approach